Hey guys, I wanted to go over a video review for for the whole test. So I'm just going to talk about the topics, um, and I guess what I would ask from it. So first two questions of the test is going to be something along about the types of discontinuity. So there's a graph version and there's the function form version, aka you can see it in the equation. So a graph removed function, it looks like this, where you have an open dot and you continue on. It doesn't matter if there's a dot there or not, like if there's an actual point. Basically here, the official, and I guess I'll tell you in the limit terms, is that the limit exists. So the limit of x approaches whatever value c does not equal whatever the actual value of said limit should be of c. So that means the limit and the actual point disagrees. Whether the point exists or not doesn't matter. It's just that the limit, it disagrees with the point. And you would know this happens if you have a function like this. Let's say you have, I'll just have it factored, x plus 2 and x plus 3, and you have an x plus 3 on top. Because you're able to cancel these out, that's what is going to be causing a removed function. So if you're able to cancel out something on top and bottom, that means that at -3 in this case, where it would be a removed type of discontinuity. So if you could remove it from the function, you could remove it from the line, which means it's a removed type of discontinuity. So jump is when this goes here and it starts somewhere else. So in this case, what it means is the limit doesn't exist. So the limit as x approaches some c from the positive value does not equal the limit as x approaches c from the negative value. AKA they go to different places. Infinity trumps that, and I'll talk about that a little bit later. But it's just that the limits do not approach the same place, okay? In terms of functions, you can't see it. The only time you would particularly see it if it's a piecewise function. So like if it was x squared plus 2 is when x is greater than or equal to 2. You plug that in, that'll be 6. Well, x minus 4 and when x is less than 2. So the limit here on this side would be if you plug in a 2. 2 squared is 4, 6. So the limit would be 6 here. Well, if you plug in a 2 here, 2 minus 4 is -2. Which means this one is like approaching y equals 6, and this one's approaching y equals 2, -2. So they're jumping from one to the other. Then they're going to follow the rule of this, whatever curve it is, or line. But it just skips that part. And because it skips that part, that causes a jump. Would never happen in something like this. That can't happen in a normal, let's say, equation, I guess, or rational function. Here, infinite function, when they either go to a positive infinity or a negative infinity, even if the situation is like a mix, let's say like a jump, and then the other part is a infinity, it will still count as an infinity. Like the infinity overruns the jump. And this is when the limit as x of c approaches, no matter which direction, positive or negative, approaches infinity. So that causes the limit as x approaches infinity. And in a function, you can see that if you have, let's say let's use the example earlier, x plus 3, x plus 2, x plus 2, x plus 3. So in this equation, the x minus 3 would be a removed limit, while here we have a denominator that if we get closer and closer, it will cause it to be 0 at -2. But as we get closer and closer, it gets bigger or smaller. So in that case here, this here, if you have let's say a 0 in the denominator, we could tell that that's going to cause a infinite function, or infinite discontinuity. So in this case, at -2, you would have an infinite discontinuity. And that's because you have something on the bottom without matching on the top. So if you cause a 0 on the bottom, that's going to cause an infinite discontinuity. All right, testing to be if it's continuous. In order for something to be continuous, that means the limit of x approaches whatever c value has to equal the same as the actual value. So f of c. Okay. So it has to match, which means what I would do is take these numbers, in this case 2, and then plug it in for each one to see the result. For example, I would plug in 2 here. This will be the limit from the, since it's bigger than 2, the positive side. This will cause it to be 7. If I plug in 2 here, so this limit, so this would be the limit as x approaches 2 from the positive side. This would be f of 2, which turns out to also be 7. This is 7. And this over here is the limit as x approaches 2 from the negative side, because it's less than 2. So that's 10 minus 3 is 7. So because all of these are 7, that means the actual limit, which matches because these match, so it must mean the limit exists, actually also equals the original point, the actual point. So in that case, this overall, all over here, is, yes, it is continuous. At 2, I would say. Over here, you have a greater than or equal to. So that takes care of the limit as x approaches 3 from the positive, along with f of 3. So you don't have to do it, like this had 3 pieces, this is only 2 pieces. Technically, this one on the right is easier. Well, I'm plugging a 3 here. So the 3 here, 3 squared is 9. 9 times 4 is 36. Minus 1 is 35. Over here, 3 times 5 is 15, plus 2 is 17. These do not match at all. So this is no. This is not continuous at 3. Sometimes I'll ask you what makes it continuous, or what c value could cause this to be continuous. So since I just said earlier, I need to make sure both of the limits match with the actual coordinate point, I need to have all this match to each other. So I'm going to set it equal to each other. C, I'll do it in color to show this is work you're doing. Cx squared plus 3x equals x minus 5. And then we're going to plug in the x values with the value we're looking at, in this case, negative 2. So it's going to be negative 2 squared is 4, so 4c plus negative 2 times 3 is negative 6, so negative 6 equals negative 2 minus 5 is negative 7. A little bit of algebra, c is going to equal negative 1/4. All right, intermediate value theorem. So you want to check if a root exists. A root means that the y equals 0. So it hits the x-axis. So you need to check if it exists. The intermediate value theorem, if you remember, it's just basically the rule, kind of like a idea that if you know the curve is continuous and you have a point on the bottom or on the top, you know no matter how you draw the curve, it needs to hit the x-axis or whatever point you're talking about. So which means I need to see if there's a y value that is both positive and negative, because then I guarantee their root exists between that. So I'm going to plug in negative 1 into this, so 6 to the negative 1 squared plus 1. That's going to be 1. 6 plus 1 is 7. If I plug in 3 into this case, 6 times 3 squared plus 1 equals 9. 9 times 6 is 54, plus 1 is 55. In this case, since they're both positive, what that shows me is that you have a point here and you have a point here. While technically you could have a curve like this that bends down and then hits the x-axis, we can't know that for a fact. All we know is for a fact that it goes to here. And because of that, if we're asking, does it exist? I would say not necessarily or no. I guess I would word the question to, is it for a fact, does it exist a point between these 2 points or something like that? A root between these 2 points? And then you will say, no, it doesn't for a fact exist. Or yes, it has to exist. So again, it's going to be a yes or no question, but you need to show your work on how do you figure that out. If they're both positive or both negative, that would imply that no, it doesn't necessarily have to happen. But if one is positive and one is negative, then yeah, it should happen. Next one, find the infinite limits. So when you're going to infinity here, there's the rule that we care about the biggest thing. So even though I have a plus a billion, I don't care because infinity is much bigger than a billion. So I'm only looking at the biggest power of the variable on both of them. So in this case, 3 as x approaches to squared, so infinity squared, over 2x. The infinity square is going to grow much bigger than infinity, which means that it's going to grow out of control. And again, I don't care about anything behind it. I don't care anything behind it. I just care about the biggest ones. So because of that, then in that case, since the top is going to grow to infinity faster than the bottom, this overall will be infinity. On this one, the bottom is bigger. So if the bottom is bigger, you're going to cause 1 over infinity eventually, right? It's going to get to infinity on the bottom. Because your denominator is so big, and the denominator being big, it makes the number really small, we're going to approach a number like 0. We're going to approach 0. So limit is 0 in that case. And then over here, if they're matching, that means that they're growing at the same rate, the infinities. Since they're growing at the same rate, they keep canceling each other out, which means the horizontal asymptote, or what they're approaching, is going to be their coefficients. Because there's 3 infinities to this 2 infinities, so the ratio is 3 to 2, or our answer would be 3 or 2. So if they're bigger on the top, it's infinity. If it's bigger on the bottom, it's 0. If they're matching, then it's the coefficients. To check if the limit causes an infinity, what we're going to do is check x as 6 approaches to the negative side. Again, you check if you can plug in 6. You can't. So we're going to check something close to 6. Let's do 5 points, or from the left side at least, because this is a negative side, so something smaller than 6. So 5.9. If I plug in 5.9 on top and bottom, on the top I'm going to get 8.9, and on the bottom I'm going to get negative 0.1, which means overall that's 89, or negative 89. Now, as I get closer, like if I put 5.99 and 5.999, you're just going to get a bigger negative number. So all I'm asking you is to plug it in once, a number smaller in it, and then see what sign it is. Since it's 89, negative 89, that case, I know the number's going to get bigger and bigger to the negative. So the answer to this question is going to be to negative infinity, because the number gets bigger to negative over and over again. All right, find the tangent line. So the tangent line, we need the formula. The formula for a tangent line, which you need to know, I'm not telling you. The limit as x approaches, as h approaches 0, we're going to take the small version of it. I remember doing, when I taught it in class, I taught you the whole thing, but we'll just take the finished product, which is f x plus h minus f of x over h. So this is the truncated formula. You need to know this. You need to know that. That being said, we're going to take this and we're going to find the tangent line of the curve when x equals 4 for this equation. So I'm going to plug it into my functions here and here. And remember, since it's x of 4, I'm going to plug in a 4 for my x's. So the first thing, I'm plugging in 4 for x. So it is going to be 4 plus h squared minus 1. This is coming from here, and this minus 1 is coming from here. Minus, let's put a big parenthesis. In here, I could plug in 4. So 4 squared is 16. 16 minus 1 is 15. So 15. Over h. Again, if I could plug in h equals 0, I would do that already, but I can't yet because there's still h on the bottom. On the top, I'm going to need to FOIL that. So 16 plus 8h plus h squared And then negative 1 minus 15 is negative 16 all over h. Well, a second, we have 16 minus 16. We could cancel those out. So we're left with, and I'm going to reorder it, h squared plus 8h over h. Well, wait a second. Everything has an h, so I could reduce everything by one h. So I cross this out, and then you could reduce this by one value. If you don't understand why that happens, let me actually draw it here. What's happening here is that we're taking an h on the top, so it'll be h plus 8 over h, and then crossing them out. What I did in both here is the same exact thing. Then we have h plus 8. At this point, we remember what we started off with here, which is a limit as h approaches 0. Because it approaches 0, we could plug in a 0 for h, which means 0 plus h, or 0 plus 8 equals 8. So our answer here is the curve, or the slope, is 8. But remember, we want the actual equation of the line, so this is not over. We found the slope. Now we're going to plug in the equation. I recommend doing the point slope form, which is y minus y1 equals mx minus x1. You can put it into y equals mx plus b form, and that would be a valid answer, but I think it takes more work. I'll show both regardless. All right. Now, before I start, I just need to know what my y value is in this equation. So in this case, when it's 4, the coordinate point is going to be 4 squared is 16 minus 1, 15. So on the left side, I'm just going to plug it in. Y minus 15 equals the slope I found, 8, over x minus 4. So I'll be done with that one. If you want to do y equals mx plus b, you're going to have to plug in all your values and find b. So 15 equals 8 times 4 plus b. 8 times 4 is 32. Subtract 32 on both sides. Negative 17 equals b. And then you could write your equation, y equals 8x minus 17. I recommend doing the left because it takes less work. You just plug it in and finish. If you're more comfortable with the right side, that's perfectly fine. All right, last one, graph given the parameters. We had a couple of homework questions like this. So graph given the parameters, when you have something like this, f of 3 equals 2, you're just literally putting a point at 3, 2. You just put a dot there. Okay? As the limit as x approaches infinity, fx equals 3. So if I'm approaching infinity, that means I'm going to the positive x value to forever. Which means what I'm going to do is my line, whatever my curve is going to be approaching 3. So I know my y value should approach 3. So I'm going to put an arrow like this as it approaches 3 to infinity. In this situation, when x approaches 2, and it works for negative infinity also, if it's negative infinity, you go to the left. For this one, as x approaches 2, it goes to infinity. In this case, what we're going to happen is as my x approaches 2, looks like my y value will become infinity. So it looks like it will be an arrow going up this way. This also could indicate that is a horizontal or a vertical asymptote here. Not only is going up this way, since it's 2 overall, it must mean on the other side it's 2. Because if the positive and negative match, that means you have the overall limit. Vice versa, if you have the overall limit, that must mean the positive and negative match. And in this one, as x approaches 3 from the negative and positive, you have different things. One's to negative infinity, the other one's to infinity. In this case, you have x approaches negative 3 from the negative side is infinity. which means on the negative side, I should be going up, so a little bit less than 3. While on the positive side, a little bit more than 3, so on the right of it, it should be going down, more like this way. Hope this helps. Use this to your advantage.